Okay. Now we're on. If you didn't notice, I put up on Slack the alternative assignment for the hackathon. So if you're not able to attend the hackathon, there is a paper to work on, and it's due end of day of Monday. So you should have some time to work on it. Otherwise, if you did sign up for the hackathon, make sure you're here by 8 a.m. on Saturday. And it goes until 8 p.m. on Saturday. If you haven't already done so, most of the team leads should have reached out. Have the team leads reached? Well, actually, Brennan, you are a team. Have you reached out? You suck. Yeah, email your team to at least just get a communication going about ideas you might want to look at. Have the rest of you heard from your teams? Perfect. Yeah, so I'll jump on the team leads today, but go ahead and email, because you did get the notification of what team you're on and who's in it. I would start emailing, at least email your team lead and start pitching some ideas or something like that. We might even have a good startup company idea come out of the hackathon. So realistically, if you're interested in doing something startup-wise for that CU launch, we can probably sign up for it and not reveal our idea yet, and then see what we want to do relative to it maybe after this weekend. But in any case, on the CU launch thing, I think it's probably going to finish sometime next semester, maybe the middle of next semester or something like that, or near the end of next semester. And in terms of your commitment to it, there's maybe 2 or 3 meetings in the evenings along the way to kind of teach you how to like storyboard out your application and kind of the entrepreneurial business startup side of things. And then outside of that, we just work on the project in our own time. But I'd encourage you to get involved in that. But in any case, so it's not like a 3 times a week commitment where you have to show up to these meetings and that kind of stuff. And all the meetings, they give you free food. So it's that. All right, yeah, so get in touch with your team leads, or team leads get in touch with your people so you can at least start brainstorming ideas, and I'll get on Slack here after class and I'll scream at people about that. Okay, so we're trying to make our person move, and I'm actually going to do this a little bit differently than we have before, just to introduce a new concept, because we want to start thinking about especially kind of in light of the hackathon, but also when you write a game, you might want it to be available for more than one device, right? So at this point, we've been kind of imagining that our games are all for a computer that has, a keyboard or something like that. Well, there's other input devices. So if you play console games, you get your little Nintendo controller or whatever that has some buttons on it. So, and you might want to use that as your input, things like that. So, you might want to write your application in such a way that changing inputs is relatively easy. To give you an example of maybe where this kind of becomes problematic is in our graduate class, we're doing some VR development. And we didn't, because we're, have a relatively small number of virtual reality headsets in the department, they've spent the first 8 weeks developing their 3D experience, let's say, in Unity, but not with VR, just using this thing called a first-person controller as they're kind of running through the world. And the thing is that up to this point, they've been dealing with button presses and stuff like that to interact with the world, and collision boxes, let's say. Well, now when we're bringing it into VR, we can start imagining new ways of interacting with the world, or new ways of accomplishing what they were doing before using keyboard and mouse. Now they're doing it in VR, even moving. When we think about how we've been, how we might move in our game, we might use the arrow keys or something like that to move, right? Once you get into VR, you're effectively standing there in a virtual world, and how do you get from here to over there? There's different ways of moving in VR. So at the hackathon, you guys will be doing things like teleportation, or there's like a kind of a drive control where you use the joystick and just kind of, drive around. But you have to reimagine the way you do things in these different environments. So you might have, alternate inputs that accomplish kind of the same thing to make your game more cross-platform. 2D games, maybe that's not quite as hugely important, but let's still look at the basics for it. So what we're going to do is we're going to create a couple of public key codes, and then we're going to set them over on the Unity side. So I'm going to create a public key code, and we're going to call this guy the up key. Public key code. Down key. Public key code. Left key. Public key code. Right key. Okay, so I have a bunch of public keys now. So let's go over here now to Unity, and that should have been exposed now to our Unity side of things. And I'll go ahead and click on Nora. Let's click on Nora more better. There we go. Or most bestest, I suppose. All right, so here's our, where's our, oh, I have not attached the script to Nora yet. Looks like no. So let's drag that script over. Big money. Cannot add components because the script class cannot be found. What? There's Nora controller. Let me just close this for a second. Let's double click on it. Okay. Now let's try adding that script over here. Maybe compile errors. I don't think we have any compile errors in here. File name and class name match. We called this Nora controller. Ah, I changed the name of it and didn't change it in here. Remember last time I was mentioning that, oh, we want to be more modular with our scripts. I think I originally called it Nora movement, and then I changed it in Unity, but that doesn't change it back into here. So we have to change the name of our class back to Nora controller. Okay, now we should be able to drag it in. Okay, so here is our Nora controller. We see that we have a bunch of keys to choose from. And let's see what we can. I really want the up, down, left, right, the arrows, if possible. Here we go. So I'm doing what, the up key first. So there's my up arrow. Notice here we have joystick buttons we can relate to. We have mouse buttons, things like that. The up button was at the very end, right? But it doesn't seem like I'd gone through this much stuff. Somewhere down there should also be touch for like mobile application stuff. Here we go. So this is down, then left, then right, now somewhere in this list there should be very generic VR buttons. So Unity itself has some generic VR support through something called OpenVR. So it's going to support, I think, just not all the buttons on those hand controls, but some basic stuff. So without doing anything special, and if you watch the video for the hackathon, we use this thing called VRTK with Unity for doing some of the virtual reality stuff. Interesting thing I saw at the conference thing last night, and I picked one up, and I did overnight shipping, so I should have it tomorrow. So I'll have it with me to demo at the hackathon on Saturday. How many of you are familiar with something called Leap Motion? Heard of Leap Motion before? So it's a project, and it's to incorporate it into other games. If you went to any of the senior seminar presentations last semester, one of the students did Brittany Klump did a project where she used Leap Motion, where Leap Motion is like a sensor, and you actually use your normal hands, and it brings it into games and stuff like that. So you could use it for Unity normally as well, and so you can reach out and grab stuff and things like that with your actual physical hands. You don't put anything on your hands. This little sensor detects it. Well, there was a company there who was in the medical industry, and they had the Leap Motion connected with an Oculus Rift. And now Leap Motion has SDKs for connecting it with a Rift. So instead of using those hand controls or the VR controls for moving around the world, they did is they was like Velcroed or something. The Leap Motion little sensor was on the front of the headset, and it was your controls. So it was actually your hands where it can detect gestures and all sorts of stuff. And it was really neat. So it appears that Leap Motion's come pretty far from even just last semester, because I know Brittany was underwhelmed with the accuracy of it, and I was messing with this thing last night. It was shockingly good, and I go onto their website now, and they have like specific kits for VR. So I think I don't know if the hardware has gotten better or the software for interpreting what the hardware is seeing has gotten better. Probably the latter, but something interesting. So there's just another possible input you might use for your games. Probably a little bit weird to have a 2D game on a computer screen using, Leap Motion hand controls, but maybe it would be cool. Another thing that we're going to get for the department, we'll mess with, we won't have it for Saturday, but brain-based input devices. So there's like a helmet you put on, and there's two different ones. We're getting the one with more sensors, so it's like 14 sensors that, basically it's a mobile EEG, so it's reading brain waves and things like that. And you use machine learning so you train it to convert your thoughts, is the idea. So like with the sample software, they have like or basically a remote control car that's in software, and you think going forward or going backwards. So you train it so you just think about, I want the car to go forward. You just think that. And whatever EEG waves it's generating, you're training that thing to do that. So now all of a sudden you can control this car with your mind. So now imagine, so this kind of goes with an artificial intelligence, machine learning type thing, where just think of all the other concepts, the other possible controls you might be able to do. If we just keep that simple, we can control Nora with our mind. We just put this, so you have this 2D game that obviously is going to be just a bestseller, right? You put this huge brain helmet and you're sitting there, you just cross your arms, and then you just think Nora go up or right or left, and Nora moves on the screen. So obviously that's where we want to go with this, to keep up with the times. But just, kind of fascinating things, and just imagine the different inputs that we might want to use for our game. Just obviously we wouldn't go that route, but the point is that you could, and I just find that fascinating. So I wonder where the lines will be, like what things can you do with brainwaves, and what things can't you do, like what won't train, or won't cross people. So I think the idea is that when you think about moving forward, the same areas of your brain kind of light up. for, you and I think that it should be the same or very similar, right? So that if I trained it to go forward, you should be able to put the helmet on, then think forward and it goes forward. And I wonder how many things are going to be true like that, or how many things are going to be very unique to an individual. So, I don't know, just kind of interesting stuff. All right, so we have our 4 public things here for our key codes. So now what we're going to do is we're going to go into our script, and we're going to do this in, I'm actually going to move this to, we'll leave it in fixed update, it's fine. So I'm going to actually change our, the way we were doing this. We're going to do this more like we did the jump button. So we're going to try to detect, in fact, I do want to move this into update just so it's, very responsive, since we're going to be detecting key presses. We might not actually notice a difference, but I'd rather just be extra responsive here. So we're going to ask some questions in here. So we're going to say if input dot get button down. So we want to know if that button is currently being pressed down. Which button? This dot up key. Let's see, is there a toString? .toString? I should be able to do it. Is there different functions that the get button down? I want one that takes a key code. Get, oh, get key pressed. Get key down, thank you. This dot up key. There we go. So if the up key is pressed, now we want to have Nora move, but we want to think about how movement's actually going to work for Nora. When we did this with our zombie baby, we used, the zombie baby was a rigid body, but we used adding force to it over a number of frames. Okay, what we're going to look at this time is we're going to look at the velocity of a rigid body. And the reason why we might want to look at the velocity is instead of, well, first of all, one issue we ran into with our zombie baby is the zombie baby was some kind of slide to a stop, something like that, because it already had this force pushing on it. And when we stopped pushing that force, it was still kind of, the impact of that force, there was follow through. Right. So now we want to try to be more discreet with instead of applying a force to the rigid body, we're just going to say this is a rigid body that is in motion and here's its current velocity. That way we should be able to stop it instantly by just setting its velocity to 0. Okay. So we're going to say if the up key is pressed, then what are we going to do? We're going to say, actually, we need to go and make sure we have a rigid body on our Nora. And we don't currently. So let's go ahead and add a component. And for right now, we'll just add the rigid body 2D. And right now we have gravity scale. So I'm going to go ahead and turn gravity scale to 0. That way gravity, because if we don't, here, if I'll leave it at 1, just as a reminder here. If I leave it at 1 and we hit play, Nora falls off the screen. If we turn it down to 0 and we hit play, gravity doesn't really impact Nora. Okay? And we probably do want to have an idle animation so that when Nora's just standing there, she's not just spazzing out. Let's go ahead and create that real quick. It won't take very long. So here is our, it's going to be, actually, let's not do that real quick. We will add it. I mean, we just have to do it 4 times because she's going to have an idle up, an idle down, an idle right, and an idle left for what she's going to look like. And then the transitions will be a little funky, but whatever. Right now, Nora is just very excited about the possibility of moving. Is the thing. Okay, so we have gravity scale set to 0. So now we don't have anything pushing against us in any direction, something like that. But we do need to keep simulated on because we do want this thing to actually be a rigid body, and simulate physics associated with that rigid body. All right, so now that we have a rigid body 2D, we can come in here, and when we hit the up key, we're going to go ahead. Let's get the rigid body for our player. So we'll do this inside of start, so we have access to it. We don't have to get component every single time. So we'll create a private rigid body 2D RB. And then inside of start, when this guy first initializes, we'll set this dot RB equal to this dot get component rigid body 2D. So now we have access to that rigid body. So if we press the up key, we're going to go ahead and set this dot RB dot velocity equal to speed. All right. Let's see. Hold on. Speed is a float. Velocity is a vector 2, probably. Yeah, good. So velocity is going to be equal to a new vector 2. We might not want to do a new vector 2 each time here. In fact, let's not do a new one here. Let's make it up here. Actually, let's make it global. That way we're not creating new ones every single update. So I'm going to create 4 more variables up here. We're going to call it a up move, down move, left move, right move. So we're going to create private vector 2s, up move, private vector 2, down move, private vector 2, left move, private vector 2, right move. All right. Now a vector 2 is going to have an X and a Y. All right. So what we're going to do is we're going to say this dot. So inside of start, we're going to initialize these. So we're going to say this dot up move is equal to a new vector 2. So this is where we'll create it the one time. And we want to make this guy move up. So it's going to be on the Y that we're going to change it. So its X is going to be 0. And the Y we want to be I think we want to set it to a 1 because we want to relate this to speed. I don't think we wanted to, well, no, actually, I think we could put speed in here. Or do we have to multiply the entire vector 2 by the speed? It actually might not make a difference if the X coordinate is a 0. I want to write it this way. I think it'll be clearer this way, and I think it'll work the same. Actually, I think the math under the hood will actually end up being the same. So I'm going to say new vector 2, 0, 1 times speed. So that's going to be our up move. This dot down move. Well, actually, before I write the down move, let's just get up move working. Make sure that guy's legit before, that way we're not copying bad code. All right, so we'll just set our up move here. And then we're going to set the rigid body velocity on the up key equal to this dot up move. All right, so whenever we hit that up key, we're going to apply to Nora's rigid body a movement in the up direction. And this is X is 0, Y is 1. So I think an increase in Y is up, a decrease in Y is down. So we'll have a -1 for down. But this should move Nora at whatever our default speed is in the up direction is the theory here. So let's save that. And let's make sure our speed is set to something. Speed is currently 0. Let's make the speed 5. I don't know how that's going to be, but we have no gravity to fight against, so it actually might be too powerful, but we should certainly see her move. All right. Actually, it didn't seem too bad. Maybe a little quick, but now we notice here, though, that when I let go of the thing, Nora's still moving because I set the velocity. Okay, the velocity is the speed in the up direction, and she's going. So I need to be able to change. Well, I need to be able to stop her if she's not moving, right? So we probably want to have a move idle or something like that, or a move stop. A little contradictory, but that's okay. We can be quirky. So we'll go ahead and create a private vector2 called stop move. And we'll set this dot stop move equal to a new vector2 0, 0. All right, and we'll go ahead and toss an else on this if here. And we'll say this dot rb dot velocity is equal to this dot stop move. So if we're not pressing the up key, make Nora stop. I really want it to detect that the stop key is still down. Is there a pressed input dot get key? Okay, that's while the user holds down the key. So instead of get key down, we just want to say get key. Because what it's doing right now, it's detecting only when I first press that key down. So I want to do input get key. And this should continuously recognize that I have the key pressed down. Okay. That looks pretty good. All right, so now let's go ahead and write the rest of the script. So let's do this dot down move is equal to a new vector2 0, -1 times speed. And actually, just as a quick test here, before I do anything else, I just want to confirm that this would have been the same. Because this is a linear algebra issue here, but since it's times 0 here, I don't think multiplying by speed actually gave us different math. Just was I think it looks better to have 1, -1, that kind of stuff. Otherwise, we're going to actually have to change our speed. So right now our speed is 3. It just happens to be going in the correct direction for us. So this should give us the equivalent up movement, I believe. Yeah. But what we would have to do if we use the speed thing for down, we'd have to say speed times -1. That's why I prefer the 1 and -1 there, and then just multiply that entire vector by speed, knowing that our x won't 0 times whatever is 0, so it's not going to impact us. All right, so that's our down move. This dot right move is equal to a new vector2, and to move to the right will be a x of 1 and a y of 0 times our speed. And to move to the left, will be an x of -1, a y of 0 times speed. Okay, so now we have our various movements. So now we just need to update to support them. So we'll say else if input dot get key this dot down key this dot rb dot velocity is equal to this dot down key, and I'll steal down move. Thank you. Then we'll steal this else if. So this is going to be right move. This will be left move. So this is right key. Right move. Left key. Left move. Otherwise, we'll stop. So now we should be able to head in all the directions, but Nora is not going to shift her animations at all. We'll do that next. Just make sure she's moving. That awesomeness. I can already tell that Nora is going to be dangerous. Okay, so now we need to make those animations work. If you remember from last time in our animator, we had our triggers for up, down, left, right. So we need to have access to Nora's animator, which is that controller. So Nora has a animator attached to her. We're going to send that animator the trigger. So back here in the code, we're going to go ahead and give ourselves access to the animator up here at the top. I'll just put this right underneath the rigid body. Private Animator, just called anim. And then inside of start, give ourselves access to that. This dot anim is equal to this dot get component animator. Okay, so now we have our animator. So whenever we move up, we're going to say this dot anim dot set trigger, and our trigger will be isn't there a we give it a string, don't we? Yeah, there was multiple versions of set trigger. One of them took an int, which is what was confusing me. So when we're moving up, we'll set the trigger up. When we're moving down, we'll set the trigger down.
What is the trigger?
Yes, we created these in our animator. No, these are the triggers here in the animator. So last time we put those in for up, down, left, right. That's what we called it. It's possible you did it differently in yours if you named them differently. So these are what we're using for our transitions here. Okay. So set trigger down for a down move, set trigger left for a left move, set trigger right for a right move, and then we just won't set the trigger to anything new when we stop. We'll just, whatever way she's facing, she'll just be still animating in that direction for right now, and that'll just be the way it is. Okay. Yeah, see, it's Because in order to do the animation for stop, we'll have to create 4 stop animations. So we'll have to have an idle up, an idle down, an idle right, and idle left. And then we'll have to keep track of what was our previous direction we were heading. And then based on that previous direction, we would set the appropriate trigger for which idle animation to play. But actually, this will, let's actually do that because it'll let me show you another another aspect of the animator. So we have this thing in the animator called any state. So this guy allows transitions from any current state to another state. Okay, so really, couldn't we have written our Nora up, Nora left, Nora right, Nora down in terms of 4 different states coming off of any state? So if we go ahead and create, let's just do this for our idle animations initially. Okay, so that way we'll just see the any state work, and then we can actually move our Nora left, Nora right, Nora down. Because wouldn't we say that this was fairly tedious? This wasn't the end of the world in this case, but we had a lot of transitions going between these. So we're going to enter in a Nora up position, or we could even enter in a Nora up idle position or something like that. So let's create those couple of animations. So we'll just pick this guy as Nora up idle. I'll just drag it into the scene here. Oh, unless we have more than one. That's unfortunate. So we'll have to build a new animation. So inside my animation folder, I'm going to say create animation. And we're going to call this guy Nora up idle. I need to be able to associate an image with how do I manually create? Can I just drop it on that? All right, so I just dropped it on the Nora up idle. I'm going to drag this in here, and I'm going to right click on Nora up idle, and I'm going to say can't I make that the default state? I'm not actually on that state machine right now. At least it doesn't appear like it, because I don't see any of my parameters over here. What did I do? Okay, now, oh, there we go. Now I can create so I'm going to say set as layer default state. So this should be Nora up idle. Let's just make sure that when my game first starts, she's facing upwards but not moving. Okay. So that was very weird how I had to create that. And there might be a better way, but that's the way I could figure out. So I'll do it for the right, left, down ones now. So I'm inside my animation folder. I'm gonna go ahead and right click. I'm gonna create an animation. So this is a blank animation. I'm gonna call this Nora down idle. Okay, now with that still selected, notice we have this little model, no model is available right now. So if I don't do anything else, let's just go back into our Nora animator. And I'm going to drag my Nora down idle up here, just so it's in the scene. And I'll actually set that one as the default state. Oh. So it's not playing any animation, but it's not also going down. So it's actually just what the base thing looks like. I haven't actually... Okay, well, let me try to do what I did before then. So I selected Nora down idle. Go back to my assets. I'll go and pick Nora image where she's facing down, drag it in there. Now let's see if she looks down to begin with. She does not. How do I associate the sprite with this? Where is the image associated? I would have assumed I could create a animation. Let's look at something here. Come on. Unity. Single frame animation. Oh, is the internet down? No, it's not. We're good. You have that. Who knows? I'll look into it. Not that important for us right now. I just can't see how we can associate an image with that. And I even looked at, Nora left where we created a actual animation. I don't see where that component the image was created there. So I'll just delete my idles for right now, and we'll just forget about those for the moment. So we want to get our next thing going. All right, so I'm down to my north, down, left, right, up. And let's get these couple of animations deleted from here. And we're back to our original state machine. Make sure she can still move. Okay, we do need to make a couple of updates to our animations here, though. This is actually in our controller. I think we want to turn our has exit time off on all of our transitions. And this will make it so that we can instantly move between our things without having to finish the previous animation, even though it's only a couple of frames. It is giving us a little delay. Okay, let's see if that makes it a little bit better. It does not. We also have to turn off fixed duration. Is that what interrupts it? This is when I click on the actual transitions inside my controller. Because what we want is we want the transitions to be able to interrupt the current state of the animation to immediately switch to the next animation. So that Nora can kind of turn on a dime. All right, well, this was better, but it's still a little weird, isn't it? So maybe the transition duration, maybe set that to 0. It was 0.25.
If we turned off our durations.
We turned off what?
If we already turned off our durations.
What do you mean if you turned off your duration?
The fixed duration you turned off. So we're
Well, I don't think so. I mean, I think that's saying that we're not requiring our guy to have a definite length because we might be transitioning out of it. But then this transition duration, I'm thinking that is the amount of time it takes to move from the current one to the next one as a percentage of the duration of this guy. Even though we have fixed duration turned off, I assume it still has a duration, whatever that duration happens to be for those frames. And since all of our animations are only 2 frames, I think fixed duration and non-fixed duration is probably the same thing for ours because it's the same frame rate and there's only 2 frames. What we have now is not horrible, but if we could just get her to not be stuck in the previous animation for a frame, that would probably be nice. Because it does look like it's only 1 frame. Yeah, that's better. So based on this, it probably doesn't matter whether you have the fixed duration on or off, since every one of our animations is 2 frames. But it looks like it was the transition time that was the big deal for us. Okay, so now we want to go ahead and make it so that she starts colliding with these other things that are in the world, right? Now we know that these guys have colliders on them, so let me go ahead and if I go to my collision layer, there's our polygon collider 2D. So now we're going to go ahead and on Nora, we're going to add a box collider 2D. And then hit play. So now Nora bumps into those things. And I think we had something up here that kept Nora from moving. All right, so right now we have an issue that it looks like Nora's bumping into the right stuff, but we really can't move across the map. So when Nora moves, how do we want the camera to follow Nora? Do we want Nora to always be centered on the screen? Let's look here and see what does Final Fantasy do. I don't think in Final Fantasy the player is always centered on the screen. Yeah, this should give us a. Well, maybe. Yeah, it looks like he is. Oh, was he? That's actually interesting because it seemed like as he walked up, well, he's centered the whole time. Okay. All right, so we want, I mean, Nora's starting off, it looks like centered on our screen. Well, not quite centered, almost centered. All right, so we just need to place Nora as a starting point at a little bit better place. Go to our scene. All right, so our All right, that should be centered. Looks like I think the camera was already placed centered. That looks pretty good for centered. All right, so now how do we make the camera move with Nora? Make the camera a child of Nora. Good. So we'll take our main camera, we'll drop it onto Nora here. So now as Nora moves, the camera moves. I don't remember where our dead spot is. Didn't we have like an imaginary dead spot somewhere?
It's all fire.
Oh, we didn't. We did it all with fire?
Yeah.
Ruh-roh. All right, so Nora just bumped into something a little funky. So Nora's actually a little bit off kilter now, right? How do we prevent that? Oh. Nora's having a bad reaction, and now, whoa. All right, so how do we prevent this? Oh, Nora's having a tough time. These. So how do I prevent Nora from getting all twisted up like that? We've done that before.
Lock the rotation.
Yeah, so we got to go to the rigid body and turn off Nora's rotation. Rotation isn't part of our movement for Nora, right? So we don't want it to be arbitrarily changed on us. So I'll click on Nora. We'll go to the rigid body, go to constraints, and we'll say freeze rotation. So freeze the thing on Z. So now Nora should be able to slam into things and not have any negative impacts. I'm pretty sure that's kind of how I had to hit it, was like move sideways like that. So Nora's locked into position. All right, so now in the ideal world, we probably wouldn't see all this fire, correct? You know, it's just kind of a boundary. Might be a little bit weird that we can't get closer to the water than this, but you know, maybe the water is kind of a hill. It's on a hill, and if you get too close, you slide down into it. They're all over golf courses like that. You know, like right by a green when you have a water hazard, there's like a steep hill, and when you decide to wear Crocs to golf in instead of golf shoes, it ends up, they're far less grippy than you think. They work great on boats, but not so much on wet grass. I obviously don't know. Okay, so in any case, let's go ahead and go to our collision layer. Now, the collision layer is just an empty container. So we actually want the thing we're going to make invisible to be our collision inside the collision layer. Actually, no, that turns off the box collider, sorry. We want the roguelike sheet, the transparent guy. We want to, you know, actually, I want to try something here real quick. I want to just take that out of the scene, because those boxes still exist. Yeah, we should still be able to collide into the boxes. All right, so originally what we were going to do is we were going to, I think I mentioned last time that you don't actually want to turn that off. You want to just turn off the mesh renderer, right? So you don't see it, but it's still there. The reality for us here, though, and actually this is good, is if we remove it completely from the scene, that means the scene doesn't have to process it. Before, we just weren't rendering it. So it's higher performance to actually remove it from the scene. So we can almost view this as a side effect of doing our show us fire for our collisions thing from the tile editor. And when we brought it in here, we can actually just turn off those game objects. So this is pretty cool that they separate the two. It's probably for this reason, would be my guess, that the actual collision box and the picture are two separate game objects. So I actually removed that picture from our scene, so it's not taking up any resources. But we can quickly throw it back in there if we needed to, if we want to see where those collisions are. All right, perfect. So now we should have a world that feels kind of, I don't know, correct? Feels like just like we're in Final Fantasy, right? These lines that get created are a little bit creepy, aren't they? I think is that an artifacting thing? Well, whatever. I mean, it keeps changing, so I wonder if we would even be there in the final game. Okay, so now one issue we have, or one thing we need to mimic, if you remember from last time, we go to the video here. It's not the button I want. Nope. There we go. All right, so we'll have him walking around here. So he's walking around and randomly at different points in time, he hits something. And now he's in a fight with a monster. And that fight takes us to a new scene that looks like this. All right, we're not going to worry about the new scene yet, but we need to be able to mimic this behavior of while I'm walking around, there's a chance I might step in something. All right, how would you implement that? Let's just talk about it out loud. So for your homework, we want to write that that ability, that we can detect that. It actually shouldn't be very hard.
An invisible box light events are triggered.
Okay, you could do that. That wouldn't actually match up to Final Fantasy very well, because in Final Fantasy, the monsters are actually not already on the screen. There wasn't like a place you could go to that's always a monster. It's literally random. As you're walking around, you just step in something.
A random variable, then you update that every now and then gets triggered.
Okay, so as we're walking around, maybe we do this on update. Maybe we do it on fixed update if we want it to be a little bit less,
Yeah, you can probably do it on fixed update because I don't think you need it.
Yeah. We can do this in fixed update, so it doesn't happen quite as often. Just from actually, a crappy machine might happen more often. But in general, in update or in fixed update, I don't think it's going to make a big difference for us. We kind of want to roll the dice, right? We want to roll the dice and say, should I hit something? Should a monster attack me? Then we need to decide, well, what's the percentage chance that we hit a monster? And you might play around with that. For testing purposes, I might set it at 10%, something like that. That way you hit monsters often enough. But in reality, maybe it's like a 1% chance, which you might think, well, that's not very high. But the reality is you're hitting update or fixed update so often that, every 100 frames, you're going to hit something statistically. That makes sense? So we need to be able to generate a random number. So just quickly here, you would just do a Google search. Actually, did we do this earlier? If we didn't, we'll just do a random number C#. I think it's like math.random or something like that. Yeah, so there's a random class, so you create a new random, same thing as you can do in Java, and then you ask that random class for the next number. Maybe you'll ask for a number between 1 and 100, or 1 and 101 to get you a number between 1 and 100 inclusive. All right, and then what you probably want to do is maybe for now, turn off Nora's renderer for like 3 seconds, then turn it back on. Something like that, letting you know that Nora hit something. Does that kind of make sense? So, this should be a relatively small assignment, but it kind of pushes us forward because the next time we'll meet is after the hackathon, and all of us have a big thing one way or another over the weekend. So, generate a random number between 1 and 100, and I don't care what you set your percentage to, but something like 10% or something like that for testing. That way Nora disappears relatively often. Sound good? All right, and then what we'll do is we'll come back next time, and we're going to look at transitioning to that next scene. completing that scene, then going back where we left off. All right. I will see everybody on Tuesday. Hopefully I see several of you on Saturday. Make sure you're here on time. Make sure you reach out to your team members. Make sure you reach out to your team leads. Like I mentioned, if you are interested in doing something entrepreneurial, message me today and we can sign up for the CU launch thing. It's actually a really good experience, and Dr. Dan Sem from the business school does a really good job with it. So I would highly, highly, highly encourage you to do that if you're willing to put in the time. All right. See you later.